what happens to the graph of a function if we do certain things to it, to the equation of the function? That's what we want to explore. It's going to be transformations of functions is what we're going to call them. And we're going to use the functions that we talked about last time, those common functions, the squaring function, the absolute value function, and those functions that we talked about when we're doing these transformations. So let's talk about one here. All right, so we've got f of x equals x squared, and we do know, hopefully, what that looks like now. Without going into too many fine details, yeah, we've got ourselves a parabola such as this, and we'll talk a whole lot more about parabolas, but what we want to do right now is look at transforming that and doing different things to the equation and see what happens. And so what I'd like to look at is then a second function here, and we'll graph it on the same thing, and I'm going to use the graphing calculator here, and we'll talk about it. All right, so if I graph, let's call it g of x equals then x squared, and we'll do x squared minus 2. G of x equals x squared minus 2, and you may know what happens there, but let's just see. All right, so we've got x squared, and then we're going to do x squared minus 2. Yeah, so x squared minus 2 turns out it's down here. Here at negative 2, we've got it, and then so the blue one is our x squared minus 2 graph. So yeah, it probably makes sense there that what happened to this graph?
It went down 2.
Everything's down 2, isn't it? If you look at it point by point, this point now is down here at negative 2. And if you go at other points, like this was 1, 1, now it's down here at negative 1. That's down 2. Down here, same thing. Yeah, each point the transformation here, it's transformed this graph, the x squared graph, and moved everything down 2. So that's a fairly nice, easy little thing. If we made it x squared minus 3, down 3. X squared plus 3, up 3. So that's a fairly easy transformation that we've got. If we tack something here on the end, plus or minus something, that's going to shift the graph either up or down. Minus 2 makes it go down. Plus 3 would make it go up 3. So that's a very nice transformation there, a very easy one. All right, now, if I go to another one then, let's make it g of x equals x minus 2 squared. Let's put on the same graph here. Maybe I should have done a whole different one, but that's all right. Let's see what happens there. Punching it in. X minus 2. First of all, hopefully there you'll note, that's got to be something different, because for one thing, if I think about it, if I squared that out, that's a whole different thing than x squared minus 2, because if I square that out, FOIL that out, that's going to give me a whole different, actually 3 terms out there. So that's a little something different than minus 2. And we'll talk about the differences here, but let's look at the graph. So if I look at the graph here, here's what this one turns out. The x minus 2 squared turns out looking right? It's over here. So instead of taking that graph, the x squared graph, and shifting it down 2, now we see what? What's the shift here? It's moved over 2, and more specifically, it's moved it to the right 2. So our shift, our transformation, is that it shifted it 2 to the right. All right, and so here's, so g of x equals x squared minus 2. That shifted it 2 units down. G of x equals x minus 2 squared. That shifted it 2 units to the right. Okay, so what's the difference? How can we make the distinction? Well, the way I distinguish it is it's an inside and outside thing. The minus 2 here is I've got minus 2 on the outside, whereas here I've got minus 2 on the inside. And so, yeah, that's going to be the distinction here that we need to make, is if I've got something added or subtracted on the outside of the function, the x squared function in this case, and it's going to work the same for other functions as well. But if I've got something on the outside, that's going to shift my graph either up or down. And if it's something on the inside, that's going to make it go right or left. Now, okay, so with that in mind here, here's kind of a summary, I guess. If we have, let's do it this way. All right, so we've got y equals f of x. Let's do it this way. If we have a g of x function where g of x is some common function, f of x, and we add to it some constant on the outside. So that's got the f of x plus c, that's on the outside. So the shift there is by what we talked about earlier with this graph. That's going to shift it, since on the outside, that's going to shift it 2 units up. So our f of x is our original function, common function. So that, if we do a g of x, f of x plus c on the outside, that's going to shift the graph 2 units, c units up. C units. Up c units. Whereas g of x, if we got it that f of x and then subtract c, that's going to shift the graph c units down. Yeah, so that's similar to the g of x equals x squared minus 2. Whatever this c is, that's how many it's going to shift down. On the other hand, if I have this g of x function and it's f, and then I've got the c on the inside, let's do all right, so that's c on the inside. What that does, well, that's analogous to the x minus 2 squared. That's going to shift it, whatever the c is, c units to the right, right? Because it's on the inside, like we had with the x minus 2 squared graph.
So it wouldn't shift to the left because it's a negative?
Is that what it did here? Mm-hmm. Yeah, that's what I'm saying. We look at the evidence here, and a minus 2 on the inside shifts it to the right.
Because it's squared.
Huh?
Because it's squared.
It sort of, that's just the way it works. Okay?
Just left. Go left.
Well, the minus goes to the right. Yeah, so it is kind of opposite what you might think. I mean, it makes sense that, yeah, it's on the inside, so it's got to do something different. And, but the minus goes to the right if it's on the inside. So yeah, guess what? If it's g of x and you got f of x plus c on the inside, guess what that's going to do? That's going to go left, yeah.
So as a rule, whatever sign is inside will change how many units it's moved in the opposite direction.
Kind of in the opposite direction, you might think, yes. That's right. Whatever, if it's on the inside, it goes opposite what you might think, what you would originally think. And we could, if you want to, we can, let's go ahead, yeah, let's go back to this one. So yeah, let's verify here if we've got g of x equals x plus 2 squared. All right, so looking at it. So I'm graphing it here. Yep, sure enough, the x plus 2 squared graph, this one right here, shows up here at -2. It's taken x squared and gone 2 to the left. So just what we think, or that's probably not what we would originally think, but based on the graph here that we've done, graphing calculator shows me that, yeah, x plus 2 squared takes everything and moves it 2 units back, 2 units to the left. So you got to keep that straight. It goes opposite what you might think. All right. You know, these are nice, but these you have to really work on probably a little bit to remember that. But yeah, the inside kind of works opposite of what you think. All right. Now, the good news is, though, if you've got it for one, then you've got it for all the common functions. It works the same way on these other common functions as well. The absolute value graph, the cubing graph, it works the same way. So let's do a couple of those here. Let's see. What about, so let's graph y equals x cubed plus 5. Well, what I'll have you do is, tell me about the transformation here and that means from the common function, our transformation. So the common function here will be x cubed. What would be the transformation? Well, that's plus 5, but where is it? Well, it's on the outside of the cubing function. And so that's going to raise it either up or down. We also could call it a vertical transformation. If it's on the outside, it's a vertical transformation. And yeah, the plus, that's the nice one. It goes like you would think. It's going to go 5 units up. And so our common function here is the x cubed. And you don't have to necessarily graph that, but think about it anyway. Because yeah, I think what I have you do is at least give me 3 points. 3 points on the the x cubed plus 5 graph, y equals x cubed plus 5 graph. And so you got 0, 0, you got 1, 1, and you got -1, -1. So that's three pretty easy points. And so if I take those each 5 units up, that's easy because now 1, 2, 3, 4, 5. You got I guess we put them over here. So now I've got a 0, that's with 5, and then if I go 5 units up here, that's going to put it at 6, right? The 1, 1 point is now at 1, 6, and then the -1 point, if I go up If I go up 6 there, where's that one at? 1, 2, 3, 4, 5. That would be at, yeah, 4. And you get more points if you want here. And then, of course, these points too, you can go back to the original equation and verify this. 0 does give you 5, 1 does give you 6, and -1. That gives me 4 because -1 cubed, -1 cubed is -1, so -1 plus 4, plus 5 gives me 4. Anyway, that's, yeah, so that's what x cubed plus 5 would look like. It's the x cubed graph up 5. All right, now, not only, well, let's do, all right, so what would this one do? Y equals the absolute value of x plus 4. We got the plus 4 on the inside. So thinking about our little chart there, table, what's that going to do?
It's gonna be right or left.
It's on the inside, isn't it?
Left.
And that one works kind of opposite what you might think. Yeah, plus 4 moves it to the left, doesn't it? So the transformation here is left 4, yes. So again, you don't have to necessarily draw the absolute value graph, but y equals, if I just do y equals absolute value of x, that's the V-shaped graph like this. And so now I've got that graph 4 to the left. So if I go 4 to the left, 1, 2, 3, 4. Now this corner, vertex, whatever you want to call it, is now here at -4, isn't it? Because everything's back here 4 units. Then this point would be here, this point would be here. That gives me 3 points. Yeah. So this graph is the V shape, but 4 units back, 4 units to the left. Yes? And like I said, I make you do a little table on these few points, and so that's pretty easy if you do. Got -5, and that's at 1. You got -4, that's at 0, and -3, it's also at 1. And you get those from from this graph or from the equation, either one. Okay? Question or problem? Okay? All right, now, can we do this? Let's see, we've got the absolute. Oh, yeah, okay, that's perfect. All right, so let's graph y equals, let's do the square root of x minus 2 and then minus 3. What do we got there?
And I know.
We got a combination, don't we, of the transformations. Not only do we have an inside, but we got an outside. So, what would the? Okay, now thinking about the order here. Which one of these would come first, the inside or the outside?
Outside.
Inside.
The inside, wouldn't it? We do the inside first. It's kind of like parentheses thing. It's on the inside, so it comes first. So think about the order here. The inside would come first, because if I was doing this, if I was plugging in a number, right? If I was plugging in a number, I would do the square root part first. So the inside comes first. So it'd be 2. So the inside I've got -2. Inside moves it right or left.
Right. Right.
So we've got a -2. That's 2 to the right. And then the outside we got a -3. So what's that?
Down.
3 down. Yep. So we got a 2 to the right and 3 down. Now the square root graph, we're just thinking about that. Here's the square root of x. And so I'm going to take that and move it 2 to the right and then 3 down. So if I follow this point, so 2 to the right puts me here, 2 and then 3 down puts me here, doesn't it? 2 to the right and then 3 down. So the starting point, if you want to call it that, is now down here at 2, -3. 1, 1, that's another good point to follow. So 2 to the right and 3 down, we put it here at 3 and -2. Let me get a table. What did I say? 2 and -3, and this one would be 3, -2. And again, if you plug them in, you can follow those too. Another good point would be 4, 2. 4, 2 would be a good point on that graph. So if I do 2 to the right and then 3 down on it, it'd be a -1, wouldn't it? So that's 6 and -1. You can do whatever points you want here. I'd like to see at least 3 points on that, because that kind of gives you the shape. I mean, you know the shape, but it kind of narrows it down. I mean, I don't want something that, you know, is real big.
Gives you a more exact graph.
More exact, yes. Thank you. All right. So there's my, I mean, you don't have to show me that, but I think it helps to see that transformation there. Okay, any questions on this combination one? You can do a right and left. I mean, a right and down, vertical and a horizontal shift right there. Is that okay? All right.